All right, here we go, part 2. Accidentally, phone shut off. So, what did we find on our densities? Did we get completely different numbers or about the same number?
About the same.
So as your hypothesis, did you say, did you think that the density would change from 3 to 5 to 7 to 9 milliliters? You said it stayed the same?
Yes.
Okay, if you said it changed, were you right or wrong? Wrong. If you said it stayed the same, okay, you're right, because density is an intensive property. It doesn't matter how much you have. Because if you go from 3 to 5 milliliters, the mass is going to increase the same amount. The density of water is 1 regardless of how much water you have. The density of alcohol is 0.789 grams per milliliter. Now, did your average come out to pretty close to 0.789?
Yes.
Okay? So we're going to be able to do, the percent error down here at the very end. Okay? But before we do that, now did everybody, now again, you need to show your work. So you need to say 28.25 grams minus the 25.75 grams equals the, what would that be? That's going to be 3 point something grams, 3.50 grams, whatever that adds up to be. That's what I want to see. Okay? Don't just put 3.50 grams. I just made numbers up, so no, I mean, I know it really comes out to closer to 2.4 grams. Okay? So each time, and then density is mass over volume. I want to see then this mass divided by the volume. And for this one, what volume should you have used? What number do you put in for V on this one right here? 3.00. Not just 3. Okay? Because we measured to 3.00. So then you get all of your answers written out, all of the digits that you get. And then you're going to round it to the proper number of sig figs, which should be how many sig figs? 3. And what are the units on density?
Grams over milliliters.
Grams over milliliters, because neither one of those cancel each other out. So I need to have a number and I need to have a unit on each answer. Then you're going to, at the very bottom, you're going to have the average. And that's going to be your 4 at 3 sig figs, your 4 values divided by 4. Okay? So that's where we should be right here. All right, now we're going to graph this. Okay? We're going to graph it. As I'm passing this out, is that 1 or 2? I think that's 2. It's 2. I think that's 3. Okay. Now once again, we're going to listen and we're going to follow directions. Everybody understands the difference between portrait and landscape, right? This is portrait. This is landscape. We're going to do our graph in landscape. Okay? Now, we have mass and volume. Now we're going to go back to biology. Which one of these is our independent variable? Which one of these is our dependent variable? Okay, the independent variable goes on the X, but which one, okay, and the dependent thing always goes on the Y. So we got that part. So which one is which? Mass or volume? Which is the dependent, which is the independent variable? Okay? What'd you say, Ford?
Volume is dependent.
Volume is dependent. Okay, what are we basing that? Give me a definition of dependent, independent. Say that again. Independent is what you change. What's the dependent? Okay, I heard somebody say it. I think you guys are all saying the same thing. What you're measuring. Okay? What you're measuring. So the independent is what you choose to change. The dependent is what you measure based upon that change. So based upon what I told you in the directions, what did we control? The volume, 3, 5, 7, and 9. And then we measured the mass of the 3, measured the mass of the 5, right? So which one is the independent? The volume. So which axis does it go on? The X. So we're going to have here, and I want you to use as much of the paper as possible, as much of the graph as possible. So we're gonna don't just put it up here in this corner like this, okay? We're gonna go big. We're gonna use as much of the graph as possible, okay? And so we just said, again, I already forgot. What do we say goes on the x-axis? Volume. And what unit is volume measured in? Milliliters. So you always put the unit in parentheses outside the label. Okay? So that makes mass go up on that y-axis. And what unit is mass measured in? Grams. Okay? Now look. We need to make sure that you label in terms of units consistently. We started with 3 milliliters. But you can't just go say 3 milliliters here and then let every 2 lines be another milliliter. Because if I did 3, 4, 5 like that, that means 2 lines is 3, but then 2 lines is only 1 here. I can't do that. It's got to be consistent. So we got to just start. You can either use 1 line, 2 lines, but again, if we want to stretch this out, we want to make it more than probably 1 line. But what's the maximum we got to get to for volume? 9. So we probably needed to say, how can I divide this up into 10? Okay? So is it every 2 lines, every 3 lines? Every 4 lines? Can I go 4 lines? Do I have room? Do I have 40 lines left to right? Maybe, maybe not, probably not. Okay? So maybe just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And then mass. The mass units do not have to be, you don't have to go 2 lines for every one. You just got to be consistent again. Mass, what's the highest we have to go to? 7 point something, right? So probably go to 8. So you might be able to go, well, I can't do it here. For me, 1, 2, 3, 4, 5, 6, 7, 8 is the best I can do on mine, but you probably could skip a line. You can probably do every 2. Okay? But you got to label. Now we're really going to have 5 points. So now do we know how to graph this? You got your 3. That's your volume. And then you got your mass, which is going to be 2 point something. That's your point. Do 3, 5, 7, 9. Then we're going to draw the line of best fit. So I'm just going to make up some points. 3, 5, 7, 5.6. Okay, you should be able to get some points that kind of look somewhere in this range. 3, what's the mass of 3? What's the mass of 5? What's the mass of 7? What's the mass of 9? And then you can have a 5th point, 0, 0, because I'm assuming that 0 milliliters would weigh 0 grams. right? Is everybody good? Now look, hey, just take 1 second, then you can go back to it. Just 1 second. Everybody look up here. Everybody look up here. Because when you're done, we're going to draw the line, the best fit line. We're not going to play dot to dot. You're just going to take, there's rulers on your tables. You spin one in between every two. You're going to play dot to dot. Now, not every point may not hit your line. All right. Okay? And then this is going to just kind of continue on up and may look like that. Okay? You want to draw the best fit line. So not every point has to hit the line. Just guesstimate with the ruler which one, how it gets closest to all of them, but use 0 as a starting point. Okay? So you just draw your best fit line. Let's go ahead and get all that. But now that you have your line drawn, but wait, there's more, okay? I want you to find the slope of your line. What is slope equal to? Rise over run. Now look, listen to me before you go do this. First off, would you want to use this point right here to try and get the slope of your line? For obvious reasons, why not? It's not on the line. It's going to be not give you a good point. You do not have to use one of your 4 points to get the slope. Okay, because you're guesstimating on that. What I recommend you do, if you went right through 0, 0, which I recommend, I kind of suggest you do, you can use that as one of your points. Then come over here and find where maybe it went right through a vertex. Just a second. Where it went right through a vertex. Then we're going to come down. Let's just say it's right there. Then we can come down and say, okay, I know that that's 9.5 here, as my run is 9.5. And then I'm right at 8, so I'm at 9.5 over 8.0. Okay, so then I can get my rise over the run. So slope M is equal to rise over run. But what's the rise equal to in this case? What's the rise a change in? What's the rise a change in? Mass. Because that's the y-axis, right? So that's going to equal mass. What's the run a change in? Volume. What is that? What is mass over volume equal to? Mind blown right here. Your slope is going to be what? What's your slope going to be the same as? Your density. And it's probably closest, hopefully, to your average density. Okay? All right. Now you can go ahead and try and do all that. I just, where did I get it? Is that the question? Yeah, just pick 2 points.
I got 0.8.
Okay. Okay, yeah, so I mean, yeah, but I guess it's going to be 8 points.
But none of them cut.
Yeah.
No, I mean like you're actually with
And then the right answer, alcohol is 6.79. So it's kind of right in between. Your slope.
Wait, it kind of looks like it. The first two. You can look online. This one is like perfect correlation. Like there was one.
You could have gone for it.
This one, I thought that was
That's where.
Look, this one's like
So you got to, so now all I would do is I'd find something where it goes right through. Oh, you should see now on here, your slope should be real similar to your average density. That's a measure of your accuracy. You know, how close were you to the right answer? Here's the right answer. This is the given density of ethanol. Okay? Now, what do you think if your points were all over it, if your line really didn't hit any of your points, what does that mean about your precision?
It's not that good.
It's not that good. So we can use how close your points are to the line, how close they are to each other. You can use that as a measure of your precision. The closer your points are to the line, the better your precision. So if all your points touch the line, starting at 0, and they all go in a line, well, that's good precision. Now, if all your points are on a line, but yet you came out to 0.75 as your density, what does that mean about your accuracy? Your precision's better than your accuracy, right? So you probably repeated something wrong. Maybe you measured the graduated cylinder wrong to start with. You're a little bit off with it, so every time you subtracted, that number was a little bit wrong, but you did everything else right, and so that just made everything a little bit too low. Okay? Now, we got 10 minutes left, or 8 minutes left, so get your Chromebooks out. We're going to do this now on a computer. Okay, once you get your Chromebooks open, you're going to go to graphical analysis. Okay, that's an app that should be preloaded on your Chromebook. Graphical analysis. It's right here. It should come up looking like this. Okay? Come on, guys. We only have y'all. We have limited time. Come on, Ford. Let's go. We have limited time. Does every graphical analysis? It's an app. It should come up and it should end up looking like a screen like this. Yeah? Now, is your data table showing? If the data table's not showing, click on this box right there. Click on that box right there. Graphical analysis board. It's an app. Just type in where your apps are. Graphical analysis. Click on this box and then hit the data table and make it show. Okay? Are the majority are almost all of us there? Okay? So now what we're going to do is we're going to put our points in. So our x-axis was mass or volume. Whoops. Click on the 3 dots on our x-axis and go to column options. What's the name of our x? Was it mass or volume? That's volume, so you're going to go ahead and type in volume. Okay? And what units are volume in?
Milliliters.
Milliliters, so type in ml. And then we had 2 decimal places. Okay? 2 decimal places. Everybody with me? Okay? Then hit apply. And then do the same thing on your y-axis, except now the y-axis is going to be what? Mass, and what are the units? Oops, mass. I got fat fingers. What are the units of mass? Grams, so just put a G, and again 2 decimal places. Apply. Okay, so now I have my units, my axes labeled. Now I need to just plug in. So start with 0, 0 right here. 0, 0. And then put your 3 and then 0.00 and put then the mass. And plug in your values. So I'm gonna just plug in some. Okay, so it should start looking like that. Okay? Once you get your 4 points, everybody's got their actually 5 points, the 0 plus then your 4. Now go down to this little square down here. The bottom left corner, the little where it's got the little dotted line. Click on that and go to apply curve fit. Okay? Now let's come back up here and get rid of your data set. Now I don't want that to show anymore, so get rid of that. So now I have this. Okay? So now I'm going to do one last thing. I want to find what's my slope. So I'm going to go back to this. Okay? And I'm going to go view statistics. Whoops. Actually, I need to go back just to apply curve fit. And it will do this.
You gotta click
Crap.
apply curve fit.
Okay? I didn't want that. Get rid of this. Okay? That's not what I want. I want to see apply curve fit. I want to see. That's what I did. That's what I didn't do. Thank you. Hit apply. Okay? So now here's my slope, 0.790. Notice that this line, I purposely made these points not on the line. Okay? So what does that mean about my precision here? These are pretty good. This I got a little, end of the day, I got a little sloppy. Okay? But look, this R value right here is a measure of your precision. The closer this number is to 1, the better your precision. This number right here, your slope, the closer it is to 0.789, the better off you are. Now, we're out of time. Well, hold on. I need you to save this. Either take a picture of the screen like this. This is what, because I needed this printed out. Tomorrow, if you can come into class, we can print this out. You can either print it out at home, you can print it out at the library, or you can come in the beginning of class and print it out here. But you got to save it. Make sure it saves, that you can retrieve it. You know where it saves to. Okay? Because we don't want to have to re-enter all this back in. I want to compare how the computer graph looks to your own graph. How your slope compares to the computer slope. Okay? Because we had to eyeball some stuff, you know, on our best fit line, whereas the computer's got okay? All right. Well, you guys have a great rest of your day, and go Jags.